Hi. So yeah, we're good. We're good. Cool. So my name's Ben. I'm a master's student at Columbia University, mainly doing computer science. But I'm very honored to be here presenting this project. So first, I'll talk a little bit about the motivation and the dataset we use for the project, and then we'll talk about a little. I'll show you a cool video of what it looks like, and then we'll go into a bit of detail of what the different user interfaces are like. But essentially, we're attempting to use virtual reality headsets and other sorts of like augmented reality, extended reality headsets to visualize Antarctica radar data. And the entire idea behind this is that usually when you do analysis with radar data, it's usually in 2D image slices, which is pretty hard to understand. You can sort of overlay things on top of each other, do some really messy things to get a idea of what the radar is showing. But if you do it in 3D and you interact with it in virtual reality, it should be a lot more smoother to analyze. So here you can see just a picture of Antarctica, very cool. And the data set that we're looking at is inside the Ross Ice Shelf over there. So at Columbia University, there's the Lamont Doherty Earth Observatory. And in 2015, 2016, and 2017, they created the ROSETTA-Ice dataset, where they basically built in-house a bunch of radar technology, flew them in airplanes over the Ross Ice Shelf, so hundreds and hundreds of lines. And yeah, we have a dataset. So next slide. This is just a picture of the Ross Archipelago, which is, again, the data set in question. You can see the Ross Ice Shelf in a little bit of it in the distance over there, and then the TransAntarctic Mountains are over here. So the reason why I'm showing this is because you'll be able to see what it looks like in virtual reality. So next slide. I think the next slide is a video, actually. Hold on. Where do I? Oh. Cool. Right, yeah, so this is a video of what the visualization looks like. So you can see that I'm flying around in virtual reality, and here are the Transantarctic Mountains. They're very exaggerated right now, but you can change the exaggeration in a couple of menus that I'll show you later. Here are different sorts of radar images that you can manipulate with. And you can also sort of walk through the ice shelf as well and see the difference between the surface radar and the bedrock as well. So here's me pulling up different images to look at. And I'll play this video again if it's a little too fast. But you can see different images and stuff. And yeah, in the background, you can see a texture of the ice flow, actually. And here's an example of what the menu looks like. So you can manipulate all of this in virtual reality. We're going back to the main menu here again. And yeah, we're zooming out. So this is actually only 1 kilometer wide. The entire data set is, I think, hundreds of kilometers wide and many meters thick. But yeah, I'll just play the video again just in case you guys missed anything. Right. So yeah, like I said earlier, you can definitely, these mountains aren't that tall. We actually, the professor who worked with us on this project was like, yeah, they shouldn't be that tall. You should definitely like add some sort of exaggeration in there to like make it much more accurate. But yeah, I think I can just go to the next slide now. Cool. So here's just another overview of everything. Here's a better image of like what the texture looks like. You can see that there's sort of this black outline that goes over the top plus this brown outline. So again, that brown outline is the bedrock. And then this black outline is like the surface radar. So you can see how, the ice flows through the ice shelf here. Let's go to the next slide. Here's just a better image of the streak line. So it's kind of hard to see with the image resolution, but there are these sort of little yellow dots that go up and down with the radar images. So these yellow dots are essentially the streak lines inside of our data set. So that's pretty cool as well. Next slide. Here's an image of the main menu. So things that we wanted to include for analysis purposes. There are different ways there are buttons to switch on and off all the radar images, which, I mean, you would want to do if you just want to look at the models or just the texture itself. We also have different things for switching off the surface DEM and the bedrock DEM, so that's available too. We also have a mini map here. We found that in our personal testing, using the VR headsets to move around with the joystick, it's actually very disorientating. There are a lot of papers on how like people can get nausea from doing that. So we have this mini map and a teleportation mode where you can sort of teleport around everywhere in the scene as well. So yeah, we can also have checkboxes to turn on and off all the different yellow streak lines that you saw, and just other options. Cool. So here's a better image of what the menu looks like. So it's kind of hard to show this in the video as well, but essentially this entire menu will be sort of like right by your face or whatever, and you can sort of like move it around as well. You can turn it on and off. That's pretty standard. But the biggest thing here is that you can see that there's vertical exaggeration and horizontal exaggeration for each of the radar images. So essentially, you can use these knobs to move to strain the image up and down, but you can also sort of use both controllers and do this. To like make the image bigger, which is also pretty cool. Another very important feature is this transparency filter that we have here. So like I said earlier, or funny anecdote that I heard about at the lab, a lot of the time to do feature extraction with radar data, one of the professors would, not officially, but like sort of informally, overlay images on top of each other in PowerPoint and then make certain images less and more transparent to like look at features, which is a little hacky, I guess. But the idea with this transparency feature is that you can sort of do that and make it much more user friendly, essentially. And you don't have to you can overlay many images on top of each other. So that's the transparency feature that we have here. And yeah, next slide. So here's another cool thing that we implemented as well for analysis. So you can see here that I'm inside measurement mode, which wasn't selected earlier. What you can do is you can mark images, mark these different circles on the images themselves. And then in the top right, that's also a little hard to see, but you can actually calculate the distance in meters between these two lines. So if you want to examine a certain feature and see how long something is or how short something is, you can do that as well. So that's pretty cool. And yeah, that's the entire presentation. I'd like to thank a couple of people. So there are 3 people who are here that presented at a poster session earlier. Dr. Alex Bogosian, Isabel Cordero, and Cheng-Yue Guo. They were all very integral to this project. And then a couple of people who aren't here, Professor Kirsty Tinto, Professor Robin Bell, Dr. Carmine Elvezio, and Sofia Zarate Sanchez. Yeah. And yeah, that's the project. I'd like to open the floor to questions if anyone has any. But yeah, thank you. Cool. Any questions? Yeah. What would I make a surprise? Biggest surprise? So the biggest surprise was probably so the lines weren't all flown straight. We assumed that they were all flown straight when we first analyzed the data set, but when looking at the radar a bit more closely, the radars were slightly curved, mainly because you can't fly airplanes perfectly in straight lines. So when you're trying to automate putting all the data inside the application, you have to sort of account for the fact that everything is curved, so you can't actually put the radar in as straight lines, which is a lot more less taxing on the computer, because you have to render everything as curves. You have to sort of do everything point-based, and that makes the entire application a lot slower. So we had to find workarounds to be able to make everything fast and running smoothly. Yeah. Yep. Thank you. Any other questions? Cool. I think that's it.